Hi, so for today we're going to continue our discussion all about the calculator techniques for engineering board exam. And for this video, we're going to talk about on how are we going to find the second derivative using the calculator techniques. So if you want to learn how to actually get the second derivative using the calculator techniques, please watch the whole video. Okay, so let's get started. So for our formula that we will be using in getting the approximation of the derivative, second derivative is this. So we have f double prime of x equals f prime x sub 2 minus f of prime x sub 1. Wherein x sub 1, we can equate this into 0.1. So meaning we will be getting the derivative of the function in the calculator with an x having a value of 0.1. That is for our x1. And then we have x sub 2. Again, this is the same process, but this x sub 1, we will be adding 1 times 10 raised to negative 5 to that 0.1. So, meaning the value of x sub 2 would be 0.1 plus 1 times 10 raised to negative 5. Okay, that's the value of the x sub 2. We will be evaluating the derivative by incrementing 0.1 a little. Okay, and that is by adding 1 times 10 raised to negative 5. And then the whole equation divided by 1 times 10 raised to negative 5. Okay, so let's get started. Okay, so for you to understand it more on how are we going to use this formula. So number one, find the second derivative of y equals x ln of x. So first of all, just for us to be safe, we need to calculate or we need to set our calculator in radian mode. Okay? So we have shift, setup, and then 4 for radian mode. So we have a radian mode. So because uh, there are derivatives that involves transcendental functions. Okay? So we have shift. We are going to calculate first that function, okay, x ln of x, alpha x, and then don't forget the parenthesis, okay, to close the ln of x. Okay, so just like what I've said, we're going to get the f prime x sub 1. Okay, and we're going to evaluate this x ln of x as x having value of 0.1. Okay, so after that, we're going to store it to our variable a. So shift RCL store to our a. So we have shifted it. Okay, we have we have already stored it in the value of a. So going back again, just press this upper sign for a replay. Okay, and this left side. So we're going to get the f prime of x sub 2. Now, by adding on our x 0.1 plus 1 times 10 raised to negative 5. So technically, we are adding a little amount of value to our x. Okay? So we have equal sign and then shift store b. Okay? Shift store the answer to b. Okay? So, and then what are we going to do? We are going to apply the formula. Okay? We know that f of x sub 2 is the value that we have stored in b, 0.1, or having an x of 0.1 plus 1 times 10 raised to negative 5, and then minus, okay, f of x sub 1, that is the derivative at x equals 0.1, which is we have stored with variable a, and then divided by 1 times 10 raised to negative 5. Okay, so if we get the answer, that would be the answer. We're going to store it to variable c. Okay, so we have stored it in the variable c. Now, let's go to the choices. So in the choices, what are we going to do is we are simply going to substitute the value of x equals 0.1. Calculate it. So, for example, in 1 all over x, okay? So that is one of the choices, choices A. We're going to calculate it using x as a value of 0.1, okay? And compare it to our variable c. And if that equals 1, then approximately equals 1, because this is an approximation formula. If that approximately equals 1, then that is the answer. Okay? So we're going to divide the answer, this 10, okay, divided by the alpha c. So we see that this is approximately equal to 1. So definitely this is the answer. So letter A. Okay? So what we did is that, again, we go to the choices and substitute directly 0.1 and compare it to the answer that we have gotten in the variable c by dividing it. Okay, so if they are equal, they must be equal to 1, approximately equal to 1. So in this case, our answer is letter C. So if we do that in our choices, in other choices, such as x squared, calculate it with 0.1, and then compare the answer by our answer in the formula a while ago, C. So we see that that is not equal to 1. Okay, that's approximately 0.001. Okay, that's not equal to 1. So we have ln of x, again, alpha of x, then solve 0.1. Okay, answer divided by the alpha c. So that's not approximately equal to 1. Of course, x also, okay? We know that if we calculate it, this would be 0.1. Okay, answer divided by alpha c, that's not equal to 1. So our answer is letter A, since 1 all over x, if we calculate it, okay, with 0.1, the answer, when we divide it by our answer in our formula a while ago, is approximately equal to 1. Okay, and I hope you learned that. Okay, so let's try again. Though this is a very easy derivative. Okay, so let's try to apply calculator techniques. So we have 8x raised to 4 plus 5 alpha x cubed, minus we have alpha x squared plus 7. Differentiate it using x 0.1, and we store the answer to A. Okay? And going back with our replay button, so we have to add 1 times 10 raised to negative 5 and store the answer again to B. And then you apply the formula. We have B minus alpha A all over 1 times 10 raised to negative 5. And store the answer to C for comparison. So let's go now to the choices. So we have first letter A, 32x squared plus x cubed, I mean. And then we have plus 15 alpha x squared minus 2 alpha x. Then solve using x 0.1. Okay, and then we have the answer. Compare it, divide it by our C. Okay, the value that we have solved using the formula. So it's not equal to 1. So let's go back to letter B. I mean, 96x squared plus 30 alpha x minus 2. Calculate x 0.1 equal sign. And then answer divided by the alpha c. So approximately this is equal to 1 since 0.999. Okay? So our tentative answer would be B. So but let's try 192 alpha x squared plus 30x. 0.1, then compare the answer with alpha c. Okay? So 2.5, that's not equal to 1. So let's try letter D just to be sure. Okay? X squared. Alpha x squared. So solve, then divide by the answer, alpha c. Oops, alpha c. That's not the answer. So technically, the answer is letter B, since we have calculated it 0.99. Okay? So checking it again, just to be sure. Okay? Okay. So answer is letter B, since it approximately equal 1. Okay, let's go now to problem number 3. Okay, so let's go now to problem number 3. So find the second derivative of y equals 2x plus 3 quantity 4x plus 2 cube when x equals 1. So we have again to the uniqueness of this problem is that it's a constant value, okay, when we get the second derivative, because we have a value of x equals 1. So we're going to evaluate what is the second derivative of this function when x is substituted equals 1 to the second derivative. So same process what that we are going to do. Okay, so we're going to input this 2 alpha x plus 3 quantity, we have 4 alpha x plus 2, and then we have raised to 3. Okay, so that is our function, and then we're going to use 1 as our x. Okay, so for our f prime x sub 1. Okay, and then we are going to store it in our variable a. Okay, and then we have to click replay here and left button here. So same process, just as like we did a while ago. Okay, we will be adding 1 times 10 raised to negative 5. Of course, because it has a value, a specific value for x, so we have to input that. Okay? So, a while ago, our problem does not involve any x, okay, values of x, so that we simply use 0.1 in approximating the second derivative. But now, if ever the problem has a value of definite value of x, then that is the one that is to be used. Okay? And the same rule, whatever value of x, we need to add 1 times 10 raised to negative 5. So if this x is 5, to get f prime x sub 2, just add 1 times 10 raised to negative 5. Okay? So, and then we calculate the derivative of this, so that this would be our f prime of x sub 2. And we shift store it into b. Apply the formula, we have alpha b minus alpha a all over 1 times 10 raised to negative 5. And the choices, okay, is actually in constant form, constant value. So this answer in our calculator should be the approximate of the correct answer. Okay, approximate. So it's very obvious that that is letter D. That is letter D. Okay? Okay, let's go now to problem number 4. Problem number 4 is involves the radius of the curvature. So the radius of the curvature is actually given by this formula. So we have quantity 1 plus quantity of dy all over dx. That's the first derivative squared. Okay, and then raised to 3 halves all over the absolute value of the second derivative of y with respect to x. So it says in the problem that we had to find the radius of the curvature of the parabola y squared equals 4x at the point 4, 4. So the very first thing that we're going to do here is to observe the formula. So we have dy and dx, first derivative, and we have second derivative. So the second derivative here in the denominator, we are going to compute it using the formula that we are using a while ago. And the first derivative here would be actually the value of a that we are storing in our calculator a while ago. This is the value of a, and this is the value of c. Okay, the result of the second derivative, and this is the value of a. So the very first thing we're going to do, if the equation is not purely in terms of y, because we need to differentiate y, only y with respect to x. So we're going to express this y squared equal 4x into purely in terms of y. So if we differentiate that, that would be having the square root of both sides, so that this side of the equation, this left side or member of the equation becomes y. So that we have square root of 4x. Okay? So it's important that this left side of the equation must be purely expressed in terms of y only. Since it has a y squared, we take the square root of both sides. Okay? So, and again, what's the value of x? Since we have a given points here, okay, we are going to substitute the value of x as 4. Okay? And differentiate that. So we need to store this in our A. Okay? And the same process we are going to do to get the second derivative from our formula a while ago. So this is 4, and then we're going to add 1 times 10, okay, raised to negative 5. And if we calculate the derivative of that, we store it into B. Okay? So we're calculating the second derivative, because we need this in our denominator here in the formula of radius of curvature. So we have alpha B minus alpha A all over 1 times 10 raised to negative 5. So store it in our calculator C. Okay, and use the formula for the radius of the curvature. So we're going to use that. So we have 1 plus, okay, okay. The first derivative, dy all over dx, that is our alpha A. Okay? And then squared according to the formula. And then this whole equation is raised to 3 halves or 1.5. Okay? All over the absolute value, okay, of the second derivative. So we need to have a shift height here for our absolute sign. Okay, and then, of course, the second derivative is the alpha c. Okay, so if we're going to compute this, we should get an answer approximately equal to the choices. So we have 22.36. And that should be our what? That should be our answer. Okay, this should be letter B, not letter C. Let me just rewrite it. Okay. Okay, so that should be the answer. Letter B, 22.36. Okay, that's one of the application of the second derivative, the radius of the curvature. Okay, so let's try another problem. So for problem number 5, still the radius of the curvature. Okay, find the radius of the curvature of the ellipse. Okay, 3x squared plus y squared equals 12 at the point 1, 3. So again, what we're going to do first is to express this equation of ellipse in terms of purely in y. So we're going to separate, okay, purely in terms of y, of the left side of the equation, purely in terms of y. So we have to differentiate. So transpose 3x squared on the left side. That becomes 12 minus 3x squared. And we have y squared here. So take the square root. So that becomes y equals square root of 12 minus 3x squared. So that becomes 12 minus square root of 12 minus 3 alpha x squared. So we have to express this left side of the equation in purely in terms of y. Okay, because we are differentiating with respect to y. So again, it has a point 1, 3. So we're going to use the value of x that is given in the coordinate, and that is 1. So we differentiate, we get an answer of negative 1, store it in our a. That's our first derivative. And of course, going back, we are going to add 1 times 10 raised to negative 5 for our second derivative. So on that, we store in b. Okay, using the formula, for the second derivative, we have alpha b minus alpha a all over 1 times 10 raised to negative 5. So we have negative 1 point something, and then we store it into c. Okay, that is the value of our second derivative. Now, we go now to the formula of the radius of the curvature. So I have 1 plus, we have dy all over dx. Again, that is our alpha a. And then squared. And then the whole equation, numerator is raised to 3 halves, which is equivalent also to 1.5. And then the absolute value of the second derivative. So we have shift height, okay, or for the absolute sign. And then alpha c. Okay. So yeah, that's the answer. So we have 2.121. Okay? So, and that is equivalent to letter C. Okay, so let's go now to problem number 6. Problem number 6, find the second derivative of y equals e raised to negative 5x plus 8 ln of 2x raised to 4. So same process we are going to do. Okay. So we have to differentiate it. Alpha e raised to negative 5 alpha x plus 8 ln of 2 alpha x raised to 4. Okay? Don't forget, close it, okay, with a parenthesis. So we have to differentiate it with 0.1. So that's, we store it into alpha a, and we have to add 0.1 to get the f prime of x sub 2 with what 1 plus 1 times 10 raised to negative 5. Okay? So again, store it in our calculator or variable b. Applying the formula, we have alpha b minus alpha a all over 1 times 10 raised to negative 5. We get the second derivative, which we store in c. And now let's go to the choices. So we have 25 alpha e raised to negative 5 alpha x, and then plus 32 alpha x raised to negative 2. Substitute the value of 0.1 and compare it with letter C. So answer divided by C, if that is approximately equal to 1, that's the answer. So that's negative 1, that's negative, okay? That's not equal to 1. So we have letter B, 15e raised to negative, okay, negative 5 alpha x. Then we have minus 40 alpha x raised to negative 2. Solve it, compare it, okay, with our answer. 1.2, still not the correct answer. So we have 25 alpha e raised to negative 5 alpha x, and then we have minus 32 alpha x raised to negative 2. So calculate it, 0.1, and then compare it with C. So that is approximately equal to 1. So our answer for this problem should be letter C. Okay. So the problem 7 is left for your assignment. Okay. So it's left for your assignment. So find the second derivative of this function. Okay. And the answer that you should get should be letter A. It should be letter A. Okay? So, guys, thank you so much for listening. I hope you learned something about this video about getting or how to solve the second derivative using our calculator techniques, as well as some of the uh, applications such as the radius of curvature. Okay? So, thank you so much for listening. God bless you, and see you again on the next video.